Today we talk about single slit diffraction. This is a drawing of the setup. I have a single slit here. The width of the slit is W. And the light coming here through the slit and makes a pattern. The pattern may be on a screen or on a wall or whatever. The pattern consists of a series of dark fringes. And the center, this is a slit. The center is a bright fringe. It's a bright. On the left and on the right, you have dark fringes. The dark fringes are equally spaced, but the central maximum is wider than the spacing between the dark fringes. Let's use M to represent the first dark fringe beside the center maximum, and the second one we call it M2, M equals 2, and M equals 3, 4, and so on. For any one of the dark fringe, let's draw a line, and this angle we call theta. There is a relation between theta, W, and the number M, and also this pattern depends on the wavelength. The wavelength of the light. And the relation is this. The slit width times sine theta equals M times lambda. Depend on which fringe you want to put this in and which fringe corresponds to the M number. This is the formula. All right, let's do some example. In this example, the lambda is given, and the distance between the center and the first dark is between center and the first dark is 0.85 millimeter. What do we want to find? We want to find the distance between the screen. There is a wall or white screen. You have the pattern projected on the screen. So what is the distance between the screen and the slit? So I want this. Let's call this L. L is what? So let's do that. Use this formula. Let's see. is this given? Oh, this is also given W. Okay, the width of the screen, width of the slit is given. So we put all the numbers into here. Between the first fringe and the center, the value of m is 1. It's 1. What is sine theta? Sine theta is the this opposite side divided by hypotenuse. Now this from here to here, this is the hypotenuse. But usually theta is a very small number. It's a small angle. Therefore, sine theta is roughly equal to tangent theta. In this diagram, tangent theta is tangent theta should be this distance divided by this distance, which is L, which we don't know. So we put the numbers, given numbers, into this equation, and we know sine theta is roughly tangent theta, and it is this, okay, opposite over adjacent. L is what we want to find. Now from here, of course, you can find L, and that's how you do it. Remember, nanometer. Nano is 10 to the negative 9th. Millimeter, of course you know, is 10 to the negative 3. So you know all the numbers, and you can find the L. Okay. The result is L is equal to you can find L. L is this, and roughly is 1 meter. So the distance between the screen and the single slit is roughly 1 meter. Let's do another example. The next example is I know this distance is given. Yeah. The distance between the first dark line and the third dark line is 3 millimeters. And in this question, what do we want to find? Let's see, okay. So we want to find, this is what? What is the slit width? And given lambda is given, what else is given? Okay, this distance is given. This distance is given. So, again, we use this formula. W is not known. So W, oh, no, sine theta. Okay. W and I want sine theta. Is equal to m lambda. Okay, so W is let's do this. Let's find the theta between the middle line and the first one. Let's find this theta. Let's find this theta. Sine theta is roughly equal to tangent theta. So sine theta is roughly equal to this distance divided by 50 cm. What is this distance? We must know another property of the pattern. The property is this. The center width is double the space between neighboring dark lines. What is the space between this one and this one? it's half of 3 millimeter. So sine theta is half of 3 millimeter. But this is equal to this. So this divided by 50 cm is sine theta. So it's roughly this. Remember, this is millimeter. Is cm, so I need to change cm to millimeter. Now I have everything in millimeter. 3 millimeter divided by 2 divided by 500 millimeter. So this is my sine theta. W is, I don't know. This is here. M is 1. Because I'm using this, m equals 1. I'm using this dark line to find the theta. Therefore, m is 1. M is 1. Lambda is wavelength is given is 690 nanometer. So this is known, m is 1, sine theta is this, therefore I can find w, and w is exactly our unknown. So put everything there. I'm not going to do the calculation. The answer is, I did it here, the answer is so W, the width is this. It is this much. So you can convert it to millimeter. Yeah, convert it to millimeter, then minus 3, yeah, it should be this millimeter. So this is our answer. Well, let's do one more example. Wavelength is given. The width is also given, W. The slit width is given. Okay. L is not given. In this case, you don't need L. You don't need L. But what do we want to find? Because there are many dark lines. There are many dark lines. So M equals 5. There are so many dark lines. The question is, how many dark lines are there total from left to right? What is the total number of dark lines? Usually dark lines are called dark fringes. Fringe, we talk about fringe. So how many dark fringes are there? Total. We still use this formula now. Okay, put the numbers in. So we put the given numbers into this formula. The wavelength is known, the slit width is known. I have two unknowns, theta and m. What is m? M equals to 1, 2, 3, 4, 5, and so on. So the m number is how many dark fringes you have, but on one side. Now if m is 8, so you have 8 dark fringes on the right hand side, and also you have 8 dark fringes on the left hand side. So what we want to know is that the whole pattern m goes to what number? If I can find the m number, then I multiply 2, I get the total number of dark lines. But what about theta? You see, for m equals 8, the theta should be this is, for m equals 8, this is the theta. But I don't know the m number. All I know is this, the dark fringes go on to very far. The dark fringes go on to very far away to the right hand side. When the dark fringes, you count the dark fringes very far away on the right hand side, the angle theta becomes larger and larger, right? So finally, the theta will be like this, and here, because the dark lines continue, so the theta, if you want to count all the dark lines here, what is theta? Theta becomes 90 degrees, right? Finally, theta is 90 degrees. So that all the dark fringes are counted. For 90 degrees, sine 90 degrees is just 1. So Sine 90 degrees is 1. So I have this equation. Now, here I have only one unknown, which is m. So I can find m. Go ahead and find m. So I did that. The answer is this is my m. So the total number, the number of dark fringes on the right-hand side is 19. So what is the total? Just multiply 2. Two times m is roughly 38. So the total number of lines, dark fringes, is 38. So that's all for a single slit diffraction pattern. And all you need to know is this general equation. So once you know that, and if you know the diagram, so there is no difficulty in solving this kind of problem. Okay, let's call this part 1 because maybe we need something, we need to go on with diffraction and next time. Thank you for watching. Goodbye.